Welcome back with another video on this channel. We are doing OWASP top 10 2021 and this is the second part of the video. So in this video we're gonna go with the cryptographic failure challenge. So I already started the attack box and the VM machine of the task, and let's go with it. Okay, so it's now time to put what we have learned into the practice. For this challenge, connect to the web application. We already connected and it is on port 81. Okay, have a look around the web app. The developer has left themselves a node indicating that there is sensitive data in a specific directory. What is the name of the mentioned directory? Okay, so in order to see the comments of the developer, so we need to see the source code here. I don't see any comments here. Otherwise it will be visible in a green color. So let's see if we have any other page. We have login page. Let's see if we see the view page. Yeah, as you can see, must remember to do something better with the database than store it in the assets directory. Let's copy this one and let's put the it should be just one /. So here we go. So we have webapp.db as well. Let's see if we can. Yeah, we downloaded it. Awesome. So here we go. It is webapp.db and we should already have the terminal open. Here we go. So let's go with the ls-l. So we have web app, so we know that we can open it with SQLite 3 and then the name of the database. Here we go. Dot tables will give us the all the tables. We have sessions and users. Okay, so let's answer the first question. What is the name of the mentioned directory? We did not copy. The name of the directory is assets. Yeah, it's correct. Now go to the directory you found in question. What the file stands out being likely be contain sensitive data. So it is webapp.db. Okay. Use the supporting material to access the sensitive data. What is the password hash of the admin user? So it should be in the users table. So let's go through the material itself. So here we go. Let's go with this particular command. Pragma table info, and we want to get the users info. It is not a must. You can directly go with the select all. We have user ID, username, password, and admin. So let's go with select static from users, and here we go. So the first one is the ID, and the password is this one. Okay, so that means this is the hash. Let's try to crack this hash using the cracknation.net. Let's put our hash here. I'm not a robot. Crack the hash, and it is QWERTY UIOP. Copy and so material. What is the password hash of the admin? Okay, so crack it. So this is the cracked version, and this is the hash version. Login as admin, and what is the flag? Okay, so this is the password. So let's go back to the where is our already running Firefox? So here it is. So we need to go to the login page. Let's go to the main page first and then login. Username is admin and password is this one. I just copy pasted this and here we go. Awesome. So within 4 minutes we are able to crack all of this. moving on to task 9, and it is third vulnerability, which is injection. So let's get into it. Injection flaws are very common in applications today. These flaws occur because the application interprets user control input as commands or parameters. Injection attacks depend on what technologies are used and how these technologies interpret the input. Some common examples include SQL injection and command injection, and many more. SQL injection. This occurs when user control input is passed to SQL queries. As a result, an attacker can pass in SQL queries to manipulate the outcome of such queries. This could potentially allow the attacker to access, modify, and delete the information in a database when this input is passed into database queries. This would make an attacker could steal sensitive information such as personal details and credentials. Command injection. This occurs when user input is passed to system commands. As a result, an attacker can execute arbitrary system commands on application servers, potentially allowing them to access user system. Okay, so command injection is a we have SQL and then we have command itself. We can run the command system commands on using the vulnerability that we'll find in the web application. The main defense for preventing injection attacks is ensuring that the user control input is not interpreted as queries or commands. There are different ways of doing this. Using an allow list. When input is sent to the server, this input is compared to a list of safe inputs or characters. If the input is marked as safe, then it is processed, otherwise it is rejected, and the application throws an error. Stripping input. If the input contains dangerous characters, these are removed before processing. That is true. Dangerous characters or input is classified as any input that can change how the underlying data is processed. Instead of manually constructing allow list or stripping input, various libraries exist that can perform these actions for you. Now, even various libraries, open source libraries, are available. If you know about the log4j vulnerability, it was there in some of the open source version of the libraries, but it was not there in the previous version of the libraries, right? So somebody deliberately tampered with that open source library, and that's why it was a global issue, right? So even though you are using open source libraries for most of the tasks, just scan your source code before you deploy it to production. Maybe you will find something. Command injection, and that's why penetration testing, manual penetration testing, is really important. Command injections occur when system-side code like PHP or C# or Java or whatnot in a web application makes a call to a function that interacts with system's console directly. An injection web vulnerability allows an attacker to take advantage of that call to execute operating system commands arbitrarily on the server. The possibilities for the attacker from here are endless. They could list files, read their content, run some basic commands to do some recon on the server, or whatever they want. It really depends, what kind of permissions they have. So the attack metrics will look like this. So if you are able to execute some of the commands on the server using the web vulnerability, then you try to see that, okay, what level of permissions I have. If I don't have permissions to run most of the commands, then I need to elevate my privileges. So the next task that you will do is to elevate the privileges. Once you elevate the privilege, that means you can run system level commands, and from system level commands you try to find out, okay, what is my target? Can this server access the database that I'm looking for? If yes, then go ahead. Otherwise, you look around or you pivot within the network to see where you need to go next. Once the attacker has a foothold on the web server, they can start usual enumeration of your systems and look for ways to pivot around. Okay, pivot around means look within the network. Code example. Let's consider a scenario. Moo Corp has started developing a web-based application for cow ASCII art with customizable text. While searching for ways to implement their app, they have come across the cowsay command in Linux, which does just that. Instead of coding a whole web application and the logic required to make cows talk in ASCII, they decide to write some simple code that calls the cowsay command from the operating system's console and send back its contents to the website. Let's look at the code they use for their app. See if you can determine why their implementation is vulnerable to command injection. So see, in a real world example, you may not have the code, but they are giving you the code just to make sure that we understand the concept itself. We will go over it below. Okay, so we have PHP opening and closing tag here. Then we have the if condition, and then we have nested if condition, and thus we have pass through here. So is set if the moving have some value, we are putting it in the moving variable, and then the cow is default. If cow is set, then we are also setting the cow variable here, and then we are passing through to a Perl executable, I think, and we are passing the parameter in here, and once the Perl executes, we just send back the result and show it on the user interface. In simple terms, the above snippet does the following. Check if the parameter moving is set. If it is, the variable $moving gets what was passed into the input field. Checking if the parameter cow is set. If it is, then variable $cow gets what was passed through the parameter. The program then executes the function pass through, and this is the command itself. The pass-through function simply executes a command in the operating system's console and sends the output back to the user browser. You can see that our command is found by concatenating the cow and moving variable at the end of it, since we can manipulate those variables. We can try injecting additional commands by using simple tricks. If you want to, you can read the docs on a pass-through on PHP's website for more information on the function itself. Okay, let's see. So this is pass through, and it is available in 4, 5, 7, and 8. And alright, warning. When allowing users supply data to be passed to this function, use escape shell args or a escape shell command to ensure that your users cannot trick the system into executing arbitrary commands. So they already pass a warning here as well. Awesome. Always check the original or the official documentation. So here we have cowsay online. It is default, and then we are putting the command or the parameter. As we can see, these command or the parameter will be executed directly within the Perl executable, and then we will get the information back like this. Alright, exploiting command injection. Now that we know how the application works behind the curtain, we will take advantage of a bash feature called inline commands to abuse the cowsay server and execute an arbitrary command we want. Bash allows you to run commands within the commands. This is useful for many reasons, but in our case, it will be used to inject a command within the cowsay server to get it executed. To execute inline commands, you only need to enclose them in the following format. So we have $, then starting the bracket and the ending of it. And then we have to mention the command itself. Okay, if the console detects an inline command, it will execute it first and then use the result as the parameter for outer command. Look at the following example, which runs who am I as an inline command. inside an echo command. Okay, so we have echo. My username is, let's try that. Why not to try it, right? Let's do it. Let's run it in our attack box. We have echo. My username is, and then $. Who am I? Let's see. My username is root. Yay! So this works, guys. So coming back to the Cowsay server, here's what would happen if we send an inline command to the web application. So if we send it like this, so it will execute it first and then it will execute the inline. It will take the output from the inline and then execute the actual command here. Since the application accepts any input from us, we can inject an inline command which will get executed and used as a parameter for Cowsay. This will make our cow say whatever the command returns. In case you are not that familiar with Linux, here are some other commands you may want to try. Whoami ID, ipconfig IP address, username dash aps dash ef. To complete the question and navigate to this particular URL, sure, let's execute our or open our browser here. Hopefully it will open today. Yes. Then copy paste it and export the Cowsay server. Sure. What we need to do is what strange text file is in the website's root directory. So first inner cows mooing. So let's go with mooing first. Let's see what it will return. Okay. Let's go with $. Who am I? Let's see what happens now. Okay, it is giving us Apache. So let's see ls minus l minus a. So we have dapper.txt, huh? I think this is what we are looking for. Awesome. How many non-root or non-service non-daemon users are there? Non-root, okay. So I think for this one, non-root. Try to ls this, and maybe this will give us bytecode dev. And what about the user? So let's go with this, and I don't know how to answer this, but let's try this user directory. And now what about we have cow, we have dev, we have root. I don't know how to answer this particular question. How many non-root, non-service, non-daemon users are there? What user is this app running as? Okay, just a moment. Let's go with the ID. we have user ID 100, which is Apache. It is running as Apache user, right? We can try to, open the etc password file, right? Just a moment. We did that before, I think, somewhere. There is a way. You just pass the file itself and you will get to know the it's not there. We can try, for example, $sign ls user bin. Let's see how many we have here. So we have a lot of stuff here. Okay, we can check the etc password file, I think. Let's see. ls etc. So yeah, we have password here. Password. Let's check this. $sign at etc password. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, maybe 9 users. How would I know? This has been ash 1. We have 2. One, 2, 3, 4, 5, 6, 7, 8, maybe 8 users. Let's try with 8. I'm not sure if the answer is right. No. 9 then. Okay, 7. I'm brute forcing. Maybe 3. The last 3. 1, 2, 4, 5, 6. Come on, man. 7, 8, 9. 1, 0. I think I tried all of it, right? Oh, 0. But there are users, man. Non-root, non-service, non-daemon users. How would we know? Not able to get this one, but let's continue. What is the user's shell set as? Okay, user's shell. Okay, so user's shell is this one, sbin and then something, no login. Copied it and paste here. Yay! What version of the Alpine Linux is running? Which version of? Okay. So this will be the uname, I think. Uname -a will give us the version. So it is 5 point something. Let's see the format here. So it is 5.4.0. Version can be found in the etc Alpine release. Okay, let's try this. And this is also a version, right? So we're gonna go with the cat and then the file itself. Here we go, 3.160. Awesome, so we have completed our challenge. So thank you for joining me on this journey. Once we come back, we're gonna go with the insecure design and the security misconfiguration. So if you like this video, please give the thumbs up. If you did not, then let me know why. Put your suggestions and comments in the comment section down below. If you haven't subscribed, please subscribe to the channel. Help us build the community. We are very few right now on this channel, and hopefully by the end of this year we will cross 10,000 mark, which is my current goal. So thank you guys for all the support, and I will see you in the next video.